Hey, what's up? You need help with your math? I guess I can help. It's kind of late. I mean, look at the time. It's almost 10 o'clock. I'm getting tired. I kind of don't want to do it right now. Oh, it's due tomorrow. Okay, well, why don't you just do it tomorrow? Oh, okay, of course you don't have time. Sure, whatever. Um, Fine. Let me just move some stuff. Okay, let's go over it. What's your first problem? Well, what are you working on? Calculus? Okay. Is this your homework or like a recap or something? Oh, okay, it's just recap. Okay, so what's the first problem you have? The integral of x. You don't know what the integral of x is? Okay, well, this is the integral. So you're going to be doing, it's the opposite of derivatives, right? So what's the exponent of x? It's x to the power of 1, right? No, you can't say right because I asked you and you didn't know. X to the power of 1. Okay, integration. What do? We add 1 to the exponent, and then we put the new number. Hey, look at me. You're not even paying attention. I'm looking right at you. Are you even gonna try? Like, it's gonna storm later, and so I don't even know if you're gonna make it to class or whatever. But I'm trying to help you, and you're not even paying attention. You're on your phone. Okay, look. This right here, x to the power of 1, we add 1 to the exponent. What do you mean we add 1? We get the exponent, whatever it is, and we plus 1. Can you do that? Yeah, you can. That's just 1 plus 1. So that's x to the power of 2. And because we have 2, we're going to get that new exponent we just got and divide what we have by 2. So x squared divided by 2. Okay, we're almost done. What kind of integral is this? What do you mean? Look at the integral. It's the integral of x dx. Is there any boundaries on it? No. So instead of evaluating it, if it had boundaries, we call that a definite integral. Do you remember this? Okay, well, this one's an indefinite integral, so there's no boundaries. What we have to do is we get x squared divided by 2 plus c. Do you remember that? I don't think you did. Okay, do you know what we did right now to get the problem? No? Okay, let's... Okay, look at the integral. It's an indefinite integral, so there's no boundaries on it. So we have to do plus c. Look over here. Look, x times dx. Dx is just part of the integral, but the function we're looking at is x. X is also written as x to the power of 1. X, 1 plus 1, divided by the sum we just have. So 1 plus 1 is 2, so it's x squared divided by 2. Do you remember that? Maybe? Okay, well, I'm trying here, but you're making it really difficult for me right now. So x squared divided by 2 plus c. And that plus c is because it's an indefinite integral. Look, if you do you want my help or not? I'm trying to help you. You're not paying attention. It is 10 o'clock now. I really don't want to do this. Because if I don't help you, I just know you're going to complain all night and I won't be able to get any sleep. So you either pay attention and follow through. Oh, you're going to follow? Okay, fine. Okay, well, that's the first answer. We're going to look at the next one, okay? We have another indefinite integral because there's no boundaries. Can you see that? Okay, well, the integral of 3x squared plus 4x plus 1 times dx. Do you see this? Okay, what kind of function is in the center? Oh yeah, I see it's adding, but like, what kind is it? Because I want you to point this out. Okay, we'll see how it's not like trig or some other weird thing. Or an exponent or something. This is... Yes, I see the x squared. That's an exponent, but that's not what I mean. I mean like exponential e to the power of x. We don't have that. It's just 3x squared plus 4x plus 1. Now, what do we know about integrals? Well, what we can do is we can, like, see this integral sign right here? Since they're all being added, we can basically look, pay attention. Look, right here, I'm going to circle this right here. This integral, you can distribute to each term. Yeah, that's a thing you can do. It's like you're not paying attention. So we have the integral of 3. Pay attention. Look, I'm writing it down. Look. 3x squared times dx. What do you mean it's not the whole problem? I know it's not the whole problem. I'm writing it term by term. Whether you want to pay attention or not, that's on you. But I'm trying to help you here. Okay. The integral of 3x squared dx. That's the first term. What we can do is add, plus, because there's a plus, the integral of 4x dx. Okay, that's what we happen when we split it up. Oh, so what's the next one? The integral of 1 dx. Okay. Do you understand that? Well, I hope so, because if you don't understand this, and we're doing this like recap this far into this semester, for this far into class, I don't know what to do. The integral, you not even look at me. Look, are you gonna pay attention? Yes? Okay, well, good, because now I'm getting annoyed. I can see you right now. If we have these 3 integrals and we to solve each one, right? Can we do that? Can you do that, actually? Well, I guess we'll find out, wouldn't we? So, 3x squared. What's one thing we can do with that? 3 times 2. Now, what are you doing? No. We have... Oh my gosh, what am I gonna do with you? That's the derivative. We're not taking the derivative, we're actually looking at the integral. Do you know what the integral is? That's the opposite of a derivative, okay? So we're not doing 2 times 3. We're doing the opposite of that, okay? So what do we have? 3 is a constant. It's a constant factor. So what we can do is we can take that out of the integral. So we can write 3 times the integral of x squared dx. Yes, I know I'm making this longer than it needs to be because you don't seem to be understanding this. I'm trying to help you. It's been a while now and you're really driving me nuts, okay? X squared. That's our problem now. So what do we do from the last problem that's similar we can do here? Okay, well, you don't seem to be understanding it. I don't know how you got this far. You are insanely stupid, okay? X squared plus, it's x squared, so we're gonna plus 1 to the exponent, so we get x to the 3, and then we're gonna divide by that new number we have, which is 3. So we have x cubed divided by 3, and then we can do a plus c, okay? And since we have the 3 in the front, we can then multiply the 3's across. We'll multiply the 3 by the answer. So the 3 in the denominator cancels. So what's the final thing we get? X cubed plus c. Okay, do you understand that? No? Of course you don't. Okay, I can see it in your face. Next term. 4x times dx. The integral of 4x times dx. Well, we can do something similar, and we can take out the 4. So it'll be the 4 times the integral of x dx. What's the integral of x? We just did it. You cannot tell me you don't understand that. Oh my god. You are driving me nuts. You know how stupid you are right now? I've never met anyone so clueless and so stupid. You, honestly, I don't even know why you're even studying this. You are so dense. You're so stupid, okay? We have 4 times the integral of x dx. The integral of x dx, which was a problem we just solved, okay? So it's x squared divided by 2 plus c. I'm not going to even work it out because I'm so done with you, okay? 4 times x squared divided by 2 plus c. Okay? 4 times x squared divided by 2 plus c. Okay, well, yes, you can also do it to the c, but it doesn't matter because it's a constant. A constant times a constant is still a constant, okay? So we can just, for the sake of writing it simpler, we're just not going to write that. 4 divided by 2 is what? 2, yeah. So it's going to be 2 times x squared plus c. Okay, now we have the next term. The integral of 1 times dx. Okay, well, yeah, this one's not x. Okay, it's a constant. What's the integral of a constant? Do you understand that? Don't know why I'm here. It has been like 10 minutes and we've gotten nowhere. You have how many math problems to solve? Oh, there's... It just keeps going. You know what? Fine, okay. X plus c. So now we have x cubed plus c plus 2x squared plus c plus x plus c. Well, all these c's are just constants. We don't know what they are, but we could just add them up. And so we're just going to get c. No, not 3c. They're actually all going to be different. They're all not equal. My mistake. I get it. But, you know, I don't even think you caught that because I'm trying to help you and you're on your phone, not paying attention. And then when you are paying attention, you're not even like mentally here, okay? You're just such an idiot, okay? We have three different constants. We add them up, we just get a constant. So our final answer would be x cubed plus 2x squared plus x plus that constant. Okay? Oh my god, you're just so stupid, okay? I don't even know why you're studying this. You are an idiot, okay? Oh, you want to do a simpler problem? Okay. Well, you tell me which problem on here you want to do next, okay? Because I don't think these are suited for you. Okay, you want to do this one? Which number is this? Number 17? Okay, number 17. What's the derivative of x cubed plus 5x? Why is the derivative here now? Do you know what the derivative is? Okay, well, you know how multiplication and division are opposites of each other? You can multiply and divide to get undo each other, and you can add and subtract to undo each other. Well, integrals and derivatives are opposite of each other, okay? We just talked about that. It has been very apparent that you don't seem to understand that. Yeah, So what's the opposite? So this is x cubed plus 5x. So what are we going to do to take the derivative? Well, now, because it's the derivative, we're going to get the exponent, bring it up front, and then subtract 1 from the exponent. Okay, that's a trick we can do. Why did I not let you do that before? Because we were taking the integral. We were taking the integral, so we can't do that. But now we're taking the derivative, so we can do that, okay? So that becomes 3x squared. No, we don't divide, because that was the integration we're doing. We do the opposite here. We add 1 to the exponent and divide for integration here. But because we're doing derivatives, we're multiplying and then subtracting 1 from the exponent. It's the opposite, okay? I'm not going to even get into when this doesn't work, but because I don't think you're ever going to get there. You know what you're doing? I don't think so, okay? Don't even pretend. I can tell you don't understand this. I don't even know why you're still taking this class. 5x. What's the derivative of 5x? No. 5x. If x is how much is the slope? Like, that's the function part. If 5x, if you plot this, you get a line. Okay? Yeah, it's a diagonal line. How much does the diagonal change? Yeah, it doesn't change. It's just a continuous ramp of 5 units. Okay, do you understand that? No, I seriously don't know how you don't get this. We're so far into the year, the semester. You have to do this. We're doing a review that you should have known this. Oh, you were just testing me? No, I can tell. I can look at you right now and tell you you are not smart, okay? You are so worthless. You cannot even solve these problems, and you'll have to pass this. I don't even know what I'm going to do with you. You are driving me nuts. You are so incredibly dense. Like, I'm trying to explain this. You're not even paying attention. I don't mind helping you, but you wait till the last minute. I really cannot stand you right now. Oh, you want me to go over all the problems? No, we're done.